Hello. This is a video recording for the final project for Finance 426 Investments. I'm looking at the workbook titled Portfolio Spreadsheet and with a worksheet called Sector Evaluation. And the idea here is that you are to fill in the green areas here. And to start with, you'll do 4 regressions here, following this regression model here, RT plus 1 equals A, which is a constant, plus B, which is a coefficient, times RT, which is lagged from RT1 plus 1. There's an error term, but that's just what's left over. It's always there in a regression model. Don't worry about it. So I'm going to do telecom. Before we do that, first you go to the Data tab, and I see data analysis here, but suppose you don't see it in your Excel worksheet. Then you've actually got to go to File, click that, go to Options, Add-ins, Analysis Tool Pack, and then say Go. Now I've previously clicked this, but you'd click it and you'd say OK, and then if you didn't see it before, you'd now see data analysis there. So, it's there. So let me first of all set up the data here. So we're going to do telecom, which is the last one here, where the coefficients are already shown. I just want to show you that I can get the same coefficients. So copy all the data here, and then copy again, I'll accept the last one. I'm going to shift down one here, paste. Let's clear this additional cell. What you see now is this is going to be our y in the regression, and this is going to be x in our regression here, representing this equation here. So having done this, I'm now ready to go to the top, click Data Analysis here, look for regression, say OK, and now let's input the y range, press Enter, click on the x range, highlight it, and then press Enter. And let's see the output. Let's collect the output here, and then make sure we click this. And now the trick here is to show 2 cells. It won't work unless you highlight 2 cells like this. And then I say Enter. So having done that, I've now entered 3 places. And I say OK. And it shows the regression model here. Looking at these coefficients, 8.11 and 0.15, what you see is they're identical. Well, I don't have space to show it, but they're identical to telecom here. So that's how it was done, to get these coefficients. I've already done these. Now, you are to go, for the next 4, repeat what I've done for telecom here. So you'll enter these, and then these zeros you see here will be calculated. They'll be non-zero then, once you fill in the green here, after regression by regression. Having said that, there's a second stage to this assignment here. And like I put 0.7 here, but it could be 0.5. But I'm kind of a 0.7 guy, so I'm going to put 0.7. So I favor more towards returns, but I also care somewhat about risk when I choose 0.7. So what to do here? So here, first of all, since I've got 0.7 here, look at these numbers that are there. Let's ignore the zeros for now. The rank is by the calculated return, by this formula where it takes delta here and uses a weighting for Q7 and Q9, which is the risk adjusted. This is Q9 and this is Q7. So it takes a mix of these two depending on your chosen risk preference here. So it takes a weighted average of these two based on delta, if you look at that formula. So having gotten that, this is now a risk-adjusted return here, because it incorporates both risk-adjusted return and just a raw return. And allows us to rank these now. So coming back, 9.7 is the highest, so this is high-tech. So I'll put high tech in here. After 9.7, the next one here is 8.53, so I'd put ENRGY. The one after that then is non-durables, and so forth. Once you fill in all 10, you'll be able to rank all 10. So next step, though, is to say, okay, let's set this to 1. 1 and enter. And these numbers all change. And this is when I cared only about returns. So this, as you can see here, this is 11.69 now, this is 11.69. There's no adjustment for risk. These are just raw returns. So I have made no adjustment for risk. So let's rank these now. What you see is here again, as it happens, high tech is again number 1. And we see that here energy is again number 2. And so forth. You'd rank these. Let's put it to 0 now. So it's giving us the same order. So, but now let's see what happens when we care a lot about risk. So we are, now you can notice that this is entirely the risk-adjusted return here. So now the number 1 here, just looking across here, is the non-durable. So we'd have a different order this time. So sometimes the rank will stay the same depending on what your choice of delta. But here, so that's the first one here. The next one is manufacturing. And, okay, sorry, I've got that. Actually, it wasn't that. It was energy. Energy is the second one. And now it's manufacturing. So, did something like that. Now, so what you see, so you complete these 10. And what you get is a ranking based upon your risk preference. And what it just shows you is, as you go from caring only about return to caring only about risk, as a portfolio manager, your ranking of these different sectors changes. So you'd make different portfolio selections. So that's what this exercise is intended to show you. So that's the end of this exercise. Going to Markowitz here, we're going to use doodle optimization here. This was discussed in class here, but here in the sort of orange or buff colored, these are the 3 constraints. And we want to end up filling in this green part here using our outputs here. But let me show you by example here. So let's do the first column here. So what we want to max, so going again to data, and here I have solver reloaded, but suppose it isn't. Go to File, Options, Add-ins, click the solver add-in and say Go. Now I already previously clicked it, but you would click it and you'd say OK, and then solver would appear here. So having said that, it's now here. Let's click solver, and well, it's still remembering. Let me just clear this out. This is all remembering my I've already played with this, so but let me clear all this out and do it from scratch. So, all right. So let's. What's our objective for the first one? Our objective is this line here, where we're going to change the objective 4 times. First of all, we want to maximize R. Because obviously we want the maximum return always. So we set this to max, and then we say, okay, click on the objective, and that's going to be this cell here. And so I highlight it and I click enter. So that's my objective. I want to have the maximum return. And by changing what cells? Well, it's going to be these cells. I'm going to change my portfolio allocation. These are the weights, and they add up to 100% or 1. So Solver will actually, by trial and error, change these, trying to get the maximum R, but subject to some two constraints in this. The other two buff cells are constraints now. So let's add a constraint, identify the cell, and it's going to be the 1, highlight it, and then say enter, and I want to set it equal to 1 or 100%. I want to have the portfolio weights add up to 100%. So I want to add one more, so I say add. You can't see it, but it's added it. So click the cell reference again, and I say now I want to add this as a constraint. So I want to maximize this, subject to that being 1, and here I want to set the constraint for, this is the variance, V. I want to have it less than 0.01. So I'm going to say enter, having highlighted this variance cell, the V cell, this is V, enter, and I want to have it, and it's already less than equal, less than equal to, so I'll put it as 0.01, and I'll say add, and I'll just say OK. I'll close this. It's now done. So I've got my two constraints, 100%, V less than 0.01, as I stipulate here. I've chosen the constraint from here. And I want to maximize R, and I want to do that by changing my weights here, my portfolio weights. So having said all of that, it's now I just click solve. And what you see here now is this is changed to 0.01. It's a feasible solution, so it's changed because we set it to be that, less than or equal to that. So it's found that it can give me a solution with this, that this is the best solution if it just sets it to the maximum. Like it could have been less than that, but Solver has found that the best risk to return ratio is found when you put it to the maximum, not less, but just set it equal. So that's the best optimum solution. This stays as 1 because it was a constraint, it was equal. There was no choice. It wasn't a less than or equal to, it was just a equal to 1. So Solver didn't change this. But as a result of trial and error, by changing, looking at this constraint and changing these portfolio weights, what it's done is the return is increased to 0.133781. So I say OK, just get rid of that. Having clicked OK, the new solution has stayed the same here. So I copy it, and I come here and I say paste. This is my solution then for given I want to maximize R, subject to this constraint being less than or equal to 0.01. This is my optimal solution, where if you look at it, almost 50% of my portfolio is going to be the T-bill. And then the next biggest is GMC, and then AT&T and USX, transportation. So that's the solution for that column. Let me do, now we're going to reverse the constraints. Let me now click Solver again, and but I'm going to do this a little differently. Let me clear that out, and I'll just go back to scratch here, just to make it. So now what I want to do is I want to start by set the objective. This time my objective is V. Let me go across here. It's not R this time, it's V. I click V, I say OK, but I'm going to change to minimize it because I want the lowest risk per unit of return. So I change to min. And how do I do this again? Again, I select the same cells to vary the portfolio weights. This is how Markowitz is done. So I've got my objective is to minimize V here by changing these weights, but I have to add my two constraints here, the other two amber cells here, or orange cells. So I'm going to add, I'm going to say this has got to be that cell, and I say equal, and I set it to equal 1, and I say add. So it's done that. Now I want to now choose the R, highlight it and enter. And here I want you to set it to be greater than or equal to 0.17. And so I say OK. And what you now see is I've got my 3 amber cells are shown here. This is to be minimized. This is to be held equal to 1. And I want this to be greater than or equal to 0.17. And solver is going to change these cells, the portfolio weights, to try to achieve these constraints. So I say solve. I say OK. And all right, one more time. L20 to minimize, change these cells. H10, and I say Q4. Okay, let me delete. Something went wrong with my other constraint. Somehow, let me delete this. I say add one, click on this, click up here, enter, and I say I want this to be greater than or equal to, I'm not sure what I did wrong here, but it's something wrong here. And now I say add, I say OK. Well, let me just close this now. And now that's correct. The cell now is correct. Somehow I ended up with the wrong cell. So that's why it didn't work. Okay, I've got my constraints here. I'm going to vary this, and I want to minimize. Somehow that changed. Let me reset this. I want to. Okay, that's correct. These are correct. That's correct. And that's correct. All right, I've got the right cells identified. And now I can solve. I say OK. So it did it. All right. So what it said, it provided, it found that the minimum of V occurred when it was at R equals 0.17, holding it at 1 here. So, and now though, let me just copy this over. Copy and paste. And what you can see now is your portfolio weights have greatly changed. Because you now have a higher return than you did before, you've shifted from the T-bill is now less, and you've shifted to GMC, which has the highest return. And you've shifted the other weights a little bit too. So you were to redo this and for your benefit and fill in the remaining columns here. And that's the end of the exercise. If you have any questions on this, by all means contact me and talk to me. There's a second part of this assignment that I'll outline in an email to you, but this is the number crunching part of it in Excel. So thank you for listening, and good luck on doing the assignment. Bye for now. I'm going to stop the